لكن مثلا ننظر يوزي يسبلوت we have an ion, and that ion is, suppose مثلا your charge دي مثلا sodium, we have a charge like sodium, and we have a water molecule which is a dipole. A water molecule is a dipole, right? So we have, suppose, a sodium ion near a water molecule. So what will be the interaction energy now, and how the interaction will vary? What will be the interaction energy? Like in charge situation, when there are two charges, we saw that when there are two charges, we saw that the energy varies is inverse of R. That's what the equivalence when there are two charges for two charges. Right? Energy, this was energy. Varies as 1 over R. When there were two charges, we saw that the energy of the system of two charges, this will vary as this, we have done this. Yes. Is inverse of R. Now what will be the situation if we have an ion, right? We have some ion, for example, Q is equal to ZE. We have an ion, and we have a dipole, and that is plus Q and minus. There is, suppose, a dipole, for example, a water molecule, and there is a charge, some charge body. And if I want to be simple, it is like a sodium ion, suppose. So what will be the form of the interaction energy of this system of? So we have done so far that we look at the electrostatic situation is one charge produces a field and another charge that is present nearby interact with the field produced by the first charge. Yes. And we write F is equal to QE. That this ion interacts with the field produced by the other charge. So here we have a charge, and that will have some field like this. This will have field here. That your field, huh? This will have a field here. They actually position the delta value of field. There will be a field produced by this charge at this point, and there will be a field produced by this charge at this point. Now we can find the interaction energy between these two charges and between these two charges. Then sum them. And that sum will be the interaction energy of the system. The interaction energy between this charge and this charge, plus the interaction energy between this charge and that will be equal to the interaction energy of this whole system. Do you understand?
Yes, sir. Yeah.
Sahi?
Yes.
So this is the electric field here, and that is the electric field. I will call it E1 or E2 something. Right? And suppose the center is like something here. That is the center, suppose, right? And it makes, suppose the dipole length is what? L is the length of the dipole. The total length is L. Right? So this point, I can say that if this is the middle, then this will be 1 over 2L, and this will be 1 over 2L. And suppose the angle that this dipole is making with this direction of the field is, that is theta. Theta is the angle which which the dipole is making with the field at this point. I may call it O or whatever. Let me call it O. Right? Okay. So suppose this is point A, right? And this is point B, and this is point C. So this distance is AB, and this distance is AC, right? So I can say that the interaction energy between these two will be equal to minus, because this is the minus charge, minus Q over 4 pi and epsilon. Epsilon I write it for
Okay.
4 pi epsilon is K, right? I can say epsilon naught and epsilon E, which is if there is a medium, for which I will write the relative permittivity, right?
Yes.
Okay. So here it will be that, and it will be the distance between these two, which is AB, correct?
Yes, sir.
The energy of a charge with another charge. And this one here, that is plus, so it will be positive energy. So here it will be like Q, again Q, and 4 pi epsilon and epsilon and or 1 over is ده سوري خمسة فرقنا بدوري فده means 1 over,
AB.
right, AB minus 1 over
Yes.
AC. See that this is the interaction energy of a charge and a molecule. Now we want to find the AB, right, and
AC.
AC. Now, if I look here, right, if I call this is R, and we call this distance is R, which is the distance from the center of the dipole to
I.
the outside charge, which is Q, right? So here I can say that, look, this will be equal to this, and I can say the here. This will be equal to something like this. This square plus this square is equal to,
This one.
right? So AB squared will be equal to, right? Okay. Okay. Look, if this is 1 over 2L, right? Then that side today will have actually a 1 over 2L cosine of theta. 1 over 2L cosine of, sorry, sine of theta. But sine. That's the recession. That 1 over 2L did that. So that's the machine 1 over 2L sine of theta. We, or that side the recession 1 over 2L cosine of theta. See? So this side whole square is equal to this side, and this is equal to total r minus this, right? This is equal to total and minus this mark. So one that will be like r minus 1 over 2 L cosine of theta whole square, eh? Which means this square, plus that is Pythagorean theorem simple,
Yes.
and plus this, and this is equal to what? 1 over 2 L, right? And sine theta whole square. सही ना? So AB will be equal to AB will be equal to जनाब R minus 1 over 2 L cosine of theta लिखा ना? Whole square plus 1 over 2 L sine theta whole square और आप इसे सिंपल over 2 शिकला, हाँ? Similarly, just over that, number 2 simple AC numbers. Right, this will be equal to, look, this will be equal to this from here to here plus from here to here. So this is from here to here is equal to R plus 1 over 2 L cosine of theta. That will be R plus 1 over 2 L cosine of theta whole square, Pythagorean theorem.
Yes.
Right? And this square 1 over 2 L sine of theta whole square to the power 1 over 2. Right? Okay. Now, if I apply the power series formula, expand this with the power series. सही है क्या? हाँ? Power series. That's number here. 1 plus x to the power n is equal to 1 plus
NX.
n x and to over 1 pictorial plus n
N
minus 1 x square over
250.
n plus,
When?
right? Sorry? Okay. So I can expand this here. I can expand this with this power formula and neglecting
Higher power.
the higher power because of the R Raubasam. सही है ना? दिन is R Raubasam first. Direct to the R Raubasam. That's it. No, that was the 1 minus 1 over 2 L over R cosine theta बची. हाँ? वही कहते ना? Double square sheet. Double square sheet. और plus 1 over 2 delta K. So then, that's what you can. सही ना? 2r और sin theta whole square will become the same. है ना? कोई भी? No, that's the one with two shoes. या तो जो r बाहर राइट स्टेशन सही ना जो r के बाहर राइट स्टेशन. No, that's the مثلا A B बराबर उस दा r जो फर्दर रोबासन बाहर होता से बड़ा सी مثلا 1 minus 1 over या L over 2r cosine theta और दा तो हम चलते शी square
Yes.
सही है ना और दूसरा plus ده شو ده r دينا نقول ده شيء L over 2r
Sphere.
and sine of theta whole square say that and to the power 1 over 2 right. Further, if we go further, right, we can write that A is equal to R, right? और जब हम लोग इसका 1 लिख रहे हैं शुक्र हाँ 1 minus 2 बची करना 2 में 2 से खत्म सी no L over R बची cosine of theta बची और क्या plus L square by 4r square को तो एक 2 और 2 से खत्म शीट L square by r square हो गया cosine theta with square theta. Similarly, this one. So that will be L square by 4r square cosine square theta. Out to the power 1. See that?
Yes.
Where r square is very greater than L.
Yes. Negative.
Therefore, L over R is very less than 1. Therefore, we neglect this case compared with 1, and therefore we neglect this case compared with 1. See the three games?
Yes, sir. Yes.
So we can write AB is equal to R and 1 minus L over cosine of power 1 over 2.
Yes.
Now I'm going to override like a power series formula. Right? So this one is the R version, right? Or that was instead of 1, or n बमुंगा y से L or R show 2r. सही था? और plus L square and 2n minus 1 बराबर कितना? No 1 over 2 और सीधे गया 1 over 2 minus 1 बची over 2 factorial or L square by R square cosine of theta. सही ना? Square and plus so on. So L square by R square again is very small as compared with 1, and the higher powers are even more small, are even smaller. So we can write this case R over 1 minus L by 2R. Now listen to cosine of theta. Here I forgot to write cosine of theta. So that is equal to this. R, I can write this as R minus L over 2 cosine of theta. That is equation number 4. Right?
Yes.
Similarly, AC equal to AC equal to R plus 1 over 2 L cosine of theta. So we put the values of AC and AB back in equation 1. A, B and AC back in equation 1. Right? Huh?
Yes.
Achha. So what we get from there, that internal energy is a function of R is equal to minus Q divided by 4 pi epsilon naught epsilon and 1 over R minus L by 2 cosine theta and minus 1 over R plus L by 2 cosine of theta. Right? We put the values of A, B and AC in equation number 1. So if we further simplify this, right, that is minus Q 4 pi epsilon naught and epsilon and take the LCM, right? So it will be R square minus L by 2 whole square will be the LCM.
Yes.
So if we simplify this, we get L cosine of theta divided by R square minus 1 over 4 L square cosine of theta whole square.
Yes.
Right? Now this is further equal to, and this is to the mu value. QL the so value mu, which is the dipole moment. Right?
Yes, sir. Yes, sir.
That is equal to the dipole moment mu. Right? Minus Q, thus mu goes to cosine of theta divided by 4 pi epsilon naught epsilon, right, over R square. Huh?
Yes, sir.
Sorry. Think over it now. Let's work with the they will push me now.
The next step is 1 L by 4. Negative.
तो क्यों बात है? चालू बात है. That's it. That's singular SQL.
Yes, yes, sir.
Then that's in there. Huh?
Yes.
Okay. So that is so the energy of a dipole. This is constant. This is supposed constant. This is constant. This is constant. This is constant. All these are constant. So the energy of a charge in a dipole are square. Our work is of two charges. The energy values is R. 1 over R. Here the energy values is 1 over R square. Come here, what is this around G?
G.
Directly. Dapat ini berzeki energi. Jika bala ain atau balik kuliah bala rikai, no kedua ain sini yo bala attraction dari masalah delta. Dan negative delta plus 3. और ये किसने attraction difference का हाँ
Yes, sir.
या study नो पदी बंदी मां दस difference के दार दस तक है कुल दस तक होते दस है कुल first का मिसर नो दस मिसर first का दस मिसर सदी दा आदि तक वेवा S मतलब और दस मिसर या F5 Чушо. Но delta energy да бия да. Да, вала energy दी वो G dipole को. ता energy से ना да उनका द dot ratio वाला वो करना. तब तो याव सीधा पहले की किसन ना R square करना. तो R square सीधे दा S by Чушо करना. तो दा पशी S square divided by 4 पशी और दा बशी F square नो दावा एनर्जी का 1/4 कम है हाफ तो नहीं if you shorten the distance by half the energy will decrease to 1/4 तो ये मतलब है कि स्क्वायर दा दी एनर्जी भी तो तेज ही सदा रहती है उसी से ताकि सेपरेशन जाते हुए नो देर पर तेज ही सदा रहती है एनर्जी का सही है ना मतलब if there is some attraction here at this position there may not be any attraction or may not be any energy between a dipole and a charge as compared with energy between two charges. So the energy of a dipole varies very fast is compared with the energy between two charges. Firstly, no, yes, we also said Q is equal to Z, some multiple of the electronic charge. Cosine of and mu and cosine of theta का स्क्वायर पर क्यों करूँ? निश्चित एक बार तो माफ कर निकले cosine of theta mu cosine of theta divided by 4 pi epsilon naught epsilon and r square. That would be the energy of a charge with charge Z E square. Z square ना है बड़ा दाम से चलो यार दाम आता देश दाम चिक मार रख ले जोन दाम दो
Yes, that's why constant grade suppose.
दाम आता चिक मार जोन दाम पे दो प्रता दा चलता
ZE is sir.
Z E so
The mu.
so that will be the energy of an ion and a dipole. Nara ji खुदा होगा फिर पुनः